Everybody talks about AI safety. What we should be talking about is AI fairness. Fairness is a model's ability to resist bias. A less fair model lets biases in the training data and labeling process compound and shift its output distribution. A more fair model withstands it and keeps producing consistent decisions despite the past inequalities, imbalanced representation, and social norms that are embedded in its training data. How do we get there? Well, you need two processes running at the same time. Auditing, measuring whether a deployed model exhibits statistical disparities across protected classes, and mitigation, modifying the data, the training procedure, or outputs of a model to reduce those disparities. You might think that these two go hand in hand, but they usually don't. They're often treated as static and separate. Auditors measure bias after the fact. Mitigation algorithms optimize against a fixed fairness definition. But these processes don't actually work together in any direct, meaningful way. There is no structured feedback loop to align the model with updated fairness goals. And there is no mechanism for the auditor to update what it measures. What we need is a way to audit and correct our models continuously. And that's where today's paper comes in. The authors propose an auditor alignment framework that wraps a model inside a loop between an auditor and a mitigation algorithm. The auditor measures bias over time. The mitigation component adapts the system in response. And the whole interaction gets structured as a reinforcement learning problem. On today's episode of Journal Club, we'll walk through the nuts and bolts of their approach, how their modules fit together, how the loop runs, and how the system converges toward lower bias over time. If you're already subscribed to our email newsletter, you'll be getting this episode in text, audio, and video form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.